All right, well, let's go ahead and get started. Thank you, everybody, for coming. It's great to see a full house here. A lot of interest in Nano server. So who here's actually deployed a Nano server? Okay, so it looks like maybe 10% of the room here. Who here is a business decision maker interested in understanding how Nano server will help them? About a quarter of the room, okay. So what Nano server is a brand new technology from Microsoft designed to really optimize data centers, make them better, make them more secure. And in this session, it's a brief one, 45 minutes. We're basically going to go through how to set it up at a high level, but then really take a look at the different management options. So we'll be very demo heavy as we go through this. The reason why management is so important with Nano server is, as you may know, there's no graphical user interface. There's not even a command prompt associated with it. So a lot of people say, I love this idea of Nano server, but how the heck am I going to use it? Who here loves writing scripts? Oh, a lot of you. Okay, well, that surprised me a little bit. Very cool. Well, lots of scripting coming up for sure. But we'll give you a great option with other types of management. I'm Simon Perriman. I'm Vice President of Business Development with Five9 Software. Previously, I spent 8 years with Microsoft. I was on the engineering team for Hyper-V and failover clustering, and then spent 4 years as a technical evangelist. Did a lot of presentations. If anyone's seen the Microsoft Virtual Academy, they may have seen me on there once or 1,000 times. But I'm here to tell you guys about Nano server, why it's great, and more importantly, how to go manage it. So first of all, introduction to Nano server. What exactly is it? So our goal here was to really try to strip down the interface, try to make things easy to manage, save money, improve security, and get more VMs on each and every host. So cost savings is the first key benefit that we like to highlight here. With Nano server, we've got rid of all of the junk. Now, many of you are familiar with server core, right? Stripped down operating system. This goes even further. This basically started from the ground of having absolutely nothing, and components were added to build the minimum set of services that were needed. Now, this contrasts with traditional Windows Server with Server Core, because the way Server Core was built is we started out with everything in full Windows Server, and we took pieces of it away. So we've kind of designed this from the ground up very differently. Now, as part of having a smaller servicing footprint, well, there's fewer reboots. The images themselves are smaller, so there's less storage space that you need. When you go and deploy a VM or transfer the data, less traffic has to go through your network. So first, cost savings, we keep things really small, really efficient. The second key benefit is around security. Who here likes reboots? I finally got one. Okay, nobody likes reboots, of course. So what we got to do with security is try to minimize the attack surface entirely. Every single component within Windows is potentially able to be attacked. Not just the core operating system or the networking stack, but every single third-party component as well. So one of the big design goals with Nano server was security. Put nothing in there, and again, build it from the ground up instead of from the top down. So fewer components means fewer servicing. That means fewer reboots, so you actually get higher availability as well. More uptime saves you guys even more money. Now with the density as well, as you'll see soon, Nano server is extremely small, very compact, very lightweight. So this means that you can get more VMs on each host. Hence, you need fewer hosts, you could save money here as well. Now as we kind of think about Microsoft's journey, they started out with the single monolithic operating system. Windows NT, Windows Server 2003. And you got it all, whether you wanted it or not. Now, Windows Server 2008 came and they started to separate some of the components. If you remember from Server Manager, the individual roles and features you now have to explicitly install. So that was kind of a good stepping stone. It meant with Server 2008, you got the core product, but then you could only add on the different features and roles that you needed. And then Microsoft also introduced a version known as Server Core. And Server Core is basically Windows Server with pieces stripped away, no graphical user interface. People like that, but the challenge when Server Core first came out with no graphical user interface was that it also had very limited remoting capabilities. And so what that meant was all of these IT pros who were used to using Windows Server 2003 with the full GUI, they now went to Server Core. They had no GUI whatsoever, no way to do any type of remote management. So it meant you really had to log in to the console and script absolutely everything. And PowerShell was just in version 1 back then as well. So scripting, doing these deployments was extremely tough. So 2012 came around and made it a little easier. Server core was significantly improved. It had remoting capabilities built in from when it was first deployed. So this meant you didn't really have to log in to that server core box. You could set it up, do a couple scripts to join it to your domain, and then remotely manage it. Things got a little bit easier. But as you're going to see here, we've almost kind of gone 180. We don't have all of those remoting capabilities set up with Nano Server because we really are cutting things down again. But you're still going to see this model, this evolution here, to really try to streamline your whole setup, your whole process. So the whole goal behind Nano Server, again, bare minimum. Less density, smaller attack surfaces. Now, one of the main reasons why Microsoft started to think about building this OS is for the cloud and these cloud-based applications. And I'm going to be talking a little bit about a traditional workload versus a cloud-based workload throughout the session, so let me just kind of explain what they mean. Now, with a traditional workload, SQL Server, your own custom application, you guys put it inside a virtual machine, and that virtual machine itself is portable. But all those different components have to live within that VM. A cloud application is slightly different. A cloud application means you're using native services that aren't running in VMs. They're their own components, their own products. So it's database as a service, websites as a service, all of these components in platform as a service. And this is the model that Microsoft is encouraging its new developers to use. Instead of going and building this beefy application that requires all of the components of the operating system, they're trying to go segment them and have your web service run as its own service. Your intelligence layer, maybe that's in a VM, maybe that's its own service. Database as a service. So part of the reason why Nano Server came out, as you'll see shortly, is to help support these lightweight, small, efficient, cloud-based applications. So keep this in mind, somewhat of this difference between a traditional workload inside a VM and a cloud-inspired workload. So with Nano Server, we got zero footprint. There's absolutely nothing that comes in it. When you go and install Nano Server, as you'll see in a couple minutes in the first demo, it's very plain. You literally boot it, you run it, you have to enter your password during the installation that you're going to use, and when you log in, you can pretty much do nothing. You have to go through this manual step again of adding all the features, adding all the roles. Now, as far as the features and roles go, it supports most of the core functionality of Windows Server that does not require any type of complicated interface. And that's maybe not the official Microsoft answer, but that's kind of the way I break it down. So for example, domain controllers, SQL Server, Exchange, those things aren't going to run directly on that Nano Server. But basic functionality, things that can be managed entirely by scripting, things such as DNS, Hyper-V, storage management, clustering, all of those are supported on Nano Server. And you're going to see this list continue to grow with each iteration. It does have full support of all the Windows drivers, which is important to help with compatibility. Now, having said that, speaking for myself as a third-party ISV, a lot of ISVs do have to do additional work to go and make their drivers compatible. So when you're going and testing Nano Server, you start to deploy it, put applications in it. As a best practice, make sure you check with your third-party ISVs, make sure that they do have Nano Server compatibility built in. Most will, but it's a testing issue. Another big change that Microsoft has made with this release is all of its anti-malware components are now included by default. So what do I mean by that? Well, if you think about Windows Server today, Microsoft, it has its own anti-malware technology known as Windows Defender. But you have to go through an additional step of installing the agent, turning it on, so that that security component can report home. Microsoft has eliminated that with the Server 2016 release, including Nano Server. All of these malware agents are now included and shipped in the box. So there's no additional step of installing these agents. You simply have to turn it on, and then it's going to be protected. So you'll see Microsoft continue to focus a lot on security with this release as well. The other two components that come installed by default here, but you have to switch on, Virtual Machine Manager Agent and Operations Manager Agent. The VMM agent essentially allows Virtual Machine Manager to communicate with it, to track it, to report on performance, CPU, all of those different metrics that it sends back to the main Virtual Machine Manager console. Same concept with Operations Manager. You install the agent in the Nano server, it's going to keep track of key performance metrics that it wants to go and send home to Operations Manager and report on. But again, these now come installed by default. You don't have to go through the additional steps of booting it for the first time, connecting to it, and going and deploy the agent with a script or with Configuration Manager. It's already included. So the whole goal here, as you'll see, is key things come pre-installed. So why is this important for cloud-based applications? Well, not necessarily first, but one of the most common use cases you think about with a cloud-based application is being able to quickly and dynamically scale. You suddenly detect that there's a high workload because maybe your company got in the news or the press. Maybe it's the holiday season and you're seeing a quick expansion in growth. Well, when you start to see this, we want to be able to dynamically scale up very rapidly. And Nano Server is going to be the key technology to do this. And so by pre-installing all of these different components, these different agents, that means that the Nano Server service can start quicker, and it's already protected, and it's already hooked into the rest of your key infrastructure. Your monitoring with Operations Manager, and your virtualization management with VMM. Now, the new technology that you may have started to hear about are Windows containers. Nano Server came about in part because of our desire to release containers. So a lot of people ask, what is a container? When do I use it? What about a traditional virtual machine? When do I use that? So the way we kind of want to break it down is, for new applications, cloud-based applications, you use Nano Server and containers. For traditional workloads you already know and love, you use Hyper-V with traditional virtual machines. So what is a container? Now, a lot of people think that a container is a new type of virtualization that's going to replace Hyper-V. It is a new type of virtualization, but it's not going to replace Hyper-V. They're going to coexist side by side because they're used for different types of applications. So the way I like to think about it here is, if you look at this image here, a traditional virtual machine, you have your hardware, you have an operating system, maybe some applications running on that host, and then you have each VM that also has a copy of the application and also has a copy of the operating system. But every time you need to redeploy that version, that virtual machine, or clone it, you have to redeploy everything. You have to redeploy that operating system. You have to redeploy the entire application. So if you kind of think about it, when you have a virtual machine, there is no separation from the OS and the application. They're kind of merged together. What containers does is we create a separation. We basically do a combination of application virtualization and OS virtualization. And this means that we essentially, in our application layer, can just segment that one component. So for example, maybe a traditional virtual machine could be my own enterprise 3-tiered application running inside the VM. Again, every time I want to copy it or scale it out, I have to redeploy that whole OS, copy that whole OS. With containers, if I want to go scale out my application, I just redeploy the application piece. So it significantly simplifies it, and again, gives you those benefits of a smaller operating system, easier to install, and easier to deploy. Now, with Windows Server, traditional containers here, we want to really think about speed and density. Every time we deploy them, we want it to be fast. And we do have that ability to quickly and dynamically scale with containers. But the great thing about containers in Nano Server is you can run a container directly on the hardware, on the host, or you could go and run a container inside a Hyper-V virtual machine. Now, it's a little confusing, right? When do I use one? When do I use the other? So the easiest way I like to think about this is, for each individual component or user which you need to isolate, put them inside a virtual machine. So if I'm a service provider and my two tenants are Coca-Cola and Pepsi, I'm going to give Coca-Cola one Hyper-V virtual machine. I'm going to give Pepsi one Hyper-V virtual machine. So they still have that isolation, that security, that privacy, all that separation that they require. But now within that virtual machine, I'm going to go and use containerization. So Pepsi can now dynamically scale up and scale back its different applications. Independently of that, Coca-Cola can dynamically scale up its applications. So this kind of gives you the best of both worlds. You get the separation between each of your different users or tenants, but you still get that scalability, that fast, rapid deployment within each of those individual virtual machines. And now Nano Server plays a key piece of this as we can be that container host. So each time I want to go and deploy my new container, it's extremely fast, helps me scale up extremely quickly. So Microsoft has already done a lot of performance testing. These numbers are based on Technical Preview 4, which came out, I think, in February, and they're about to release the new numbers for RTM. Perhaps they've even done it yesterday or this week. Now, the whole goal around this is the speed, the efficiency, the performance, right, but also the security. So if you take a look at this screenshot, this is comparing Nano Server versus Server Core on Technical Preview 4. You have to start with fewer drivers. What does that mean? Well, there's fewer components to attack, and it's going to boot faster. There's fewer services that need to run on it. So that means it's more efficient. It can start faster. Fewer pieces to attack. Fewer ports are open. Again, a smaller attack surface. Fewer processors running. It's going to be more performant. The amount of memory, the amount of I/O it takes to go and boot, amount of disk space, it's about a third. So this means that your startup time is faster. And when you go and deploy these virtual machines, you have to deploy less each time, so the deployment's quicker. The amount of memory to run the kernel, the brains of the operating system, again, significantly less than half. But the deployment size here is probably the biggest differentiator that we see. The setup time to go and install the entire operating system, 40 seconds. The footprint, the amount of file size it takes, 400 megabytes instead of 5.5 gigs. VHD size, 400 megabytes instead of 6 gigs. So think about that. If you're running 1,000 virtual machines in your data center, and you can go and save, what, an eighth of the processing speed here, I mean, that's significant savings that you have here. Quicker to deploy, quicker to scale up, and you can run more virtual machines and services on each of your individual hosts. So maybe you don't even need to go buy storage for the next couple of years as well, because you've already recovered and saved all of this. And don't forget, even past this, you can still do deduplication, put things even smaller as well. So let's go ahead and kind of walk through some of the steps required to go and install a Nano server. Now, when you actually go and download the Windows Server 2016 binaries, Technical Preview 5, or even the full version, what you're actually going to see here is a new directory for Nano Server, a folder. But one thing that's kind of unusual is if you're actually going through the traditional GUI-based installation, where you select custom installation, you select which drive you're going to do it on, you won't see an installation option for Nano Server. Only way you can go and install Nano Server is through a series of steps that do involve scripting right now. So it's slightly different. Now, to make this easier, as you're doing the scripts, Microsoft has included sample scripts, sample images, as part of the actual files that you receive when you get Windows Server 2016. They have some commandlets that are built in to deploy the new Nano server, or to convert different types of images, a .wim image, over to a Nano server image. And you could go and use these to deploy a Nano server as a host or as a virtual machine. So very flexible deployment options. Now, as you go through the process of actually creating this, you want to make sure that you add all of your drivers, of course. You then go and manually add all of the roles. You set the administrator password upon deployment, and you will go and convert the Windows image to a virtual hard disk. Now, with the virtual hard disk, if you're booting directly on physical hardware, you basically do a boot from VHD. It's that same VHD that's going to be used for the host or for the virtual machine. Now, beyond that, there's a couple different options that you can turn on as well. Configuring names, IP addresses, joining a domain, dual boot, meaning you want to boot to the VHD, or do you want to go and boot the host to a traditional operating system? EMS we'll talk about in a second, and then go and install in different agents and tools. So with the drivers, Microsoft does include all of the core drivers with the installation. Additionally, you could go find these third-party drivers online. So we try not to make the driver process too complicated, but it is different than installing this traditional operating system. Again, keep this concept in mind. Instead of going from the entire Windows server and cutting things away, we're starting from nothing and building things up. So this means as we build it up, we got to go add the drivers that are necessary. Now, when you go and install the features and roles, all of this is done through command again. We'll walk through this momentarily in the demo, but you'll see we actually have these folders, and you go and specify each of the different types of features and roles which you want to go and add. Now, the Emergency Management Console, or EMS, that other component, what this does is it allows you to go and do some basic testing, connect to the virtual machine, if it's very isolated. So one of the challenges with Nano Server is there's no graphical user interface at all, and there's not even a command prompt running on the Nano Server. You'll see once we go and boot one up that there's basically nothing. You log in, and you have a couple of options, such as configure firewall, configure network settings. But what we found is there were some users, some customers that would go and change some firewall setting or some type of network setting, and they could never connect to their Nano Server VM again. It's tough, right? So what Microsoft has done is they've offered this kind of a workaround to be able to access it, known as the Emergency Management Console. And what it does is it basically spoofs a port that's directly connected to the Nano Server and gives you keyboard access and allows you to do some basic commands, such as reconfiguring the domain or the network adapters. So it's kind of like, if you lock yourself out, it's kind of like a skeleton key, kind of get you back in, unlock yourself, and then go back to traditional management as well. So let's go ahead and switch over to the first demo here, and we'll actually go deploy a Nano Server and take a look at how that looks. So I have my cheat sheet here. I'm not going to pretend that I can memorize all of this, but it's not too much, and you'll find lots of great demos and lots of great scripts online. So first thing I got to do is launch PowerShell as an administrator. And we're going to go ahead and change my directory here. And what we're essentially going to do is go into this file system that I have here. And this is basically a version of Windows Server 2016, Technical Preview 5, mounted on my E drive. I can see if I click Setup, it's going to go give me the graphical user interface, full installation options, server core. And you'll notice we have this separate folder here for Nano Server. Again, if you install Nano Server, you don't have the GUI installation option. You've got to go through the scripting process. So first thing that we want to do here is set the execution policy for remote signed. And this is a relatively common PowerShell commandlet that basically says that you can go and run remote commands. And this is going to be important because we're on one system deploying a second system. The next thing that we're going to do here is import a module which will actually go and generate the Nano Server image. So what that's done here is it's going to take these Nano Server binary files, these packages, and it's gone and converted to a WIM image, or an installable media image. Now the next thing is the core commandlet that's actually going to go and create this. And what we're going to do is we're going to kick this off. It takes 3 or 4 minutes to actually complete, so we'll switch back to the slides and let it run in the background. So let's go ahead and kick it off here. And notice here, it's actually asking me for an administrator password. This is not the admin password for my local system. This is the admin password that I'm going to inject inside the virtual machine, inside the Nano Server VM. So important thing here, a lot of people make a mistake here. So we're going to go and configure the password, and then you're going to see a process where we're copying the files, deploying the WIM images. But essentially what we've done here is we said we're going to create a new Nano Server image, standard edition, deploy it as a guest operating system, so as a virtual machine. We specify the media path, so that's my E drive. We specify where I want to go and copy the file to. And then we go and specify the name of this new Nano Server that we're going to create. We'll call it Nano Ignite. As you'll see here, it goes through a process, formatting everything, turning it on. And after a couple minutes, it's going to go and create that new image for us. So let's go ahead and take a look at the management options now, since we've gone and done the installation. So the good thing is there are lots of different types of management options that do have a full graphical user interface. All of these are done remotely, though. Keep that in mind. You're not going to be doing anything directly on the Nano Server. You're going to go and connect to it remotely. So PowerShell Core is one of the first ones, and this is a stripped-down version of PowerShell. Now, as you guys have probably seen over the last couple of years, PowerShell has become an extremely useful tool. And you can run commandlets for pretty much any Windows server and most third-party applications. But for example, you can't go and do a PowerShell commandlet for SQL Server on Nano Server because Nano doesn't support SQL. So one of the ways that Microsoft has kind of simplified this process and not had people get confused about what works or what doesn't work is they've created a stripped-down instance of PowerShell known as PowerShell Core. All of these commandlets are going to work against Nano Server. And so you're not going to hit issues where you'll run a long commandlet. It will process stuff for a couple of minutes and error out. It's going to explicitly block it up front. But it still gives you kind of the core functionality, creating storage, networks. 90% of what you'd want to do is still going to work. There's just a couple of things that don't run in Nano Server that you don't have access to. Now, the second one is called Server Management Tools. I'm going to talk about this more on the next slide. But it's a new stripped-down GUI released by Microsoft that will allow you to do different types of configuration and do some basic monitoring of things like the performance and task manager. Again, we'll come back to that. We then have Server Manager, the full graphical user interface you guys are probably familiar with for a while. And with Server Manager, we could go and attach it to Nano servers. We can create storage for them. We could do things such as create an iSCSI target. So a lot of the basic functionality you still have with Server Core, we can remotely connect to on Nano Server. Hyper-V Manager, we can deploy our Nano Server virtual machines, configure our disks, our networks, just like it's a normal virtual machine. Now, from the outside perspective, with Hyper-V Manager, it is just a normal virtual machine. We configure memory for it. We configure network connections. We configure storage. We configure virtual hard disks. Where you'll start to find limitations around Nano Server is when you want to do actions within that guest operating system. We'll go through some of those shortly. We then have Failover Cluster Manager. This is what we use to deploy and manage our clusters. Full Nano Server support in this. Again, you'll start to only see limitations when you need to actually test, deploy, and run things within that guest operating system. And finally, Five9 Manager. This is a third-party application. In fact, today we've released our Nano Server version of it. And with Five9 Manager, we have full GUI support for managing all of your Nano Server components, including monitoring within it as well. And we'll go show a demo of that a little later, too. But let's go back to SMT, the second one that we have on the list here, Server Management Tools. So again, this is brand new with Windows Server 2016. This is a graphical user interface that runs on top of a website. It kind of looks like Azure, right? Like the Azure portal, and that's kind of the design, trying to have that similar look and feel of Azure. What Server Manager does is it essentially allows you to do all the configuration and all of the monitoring. So you can remotely connect to that Nano server and do basic functionality. Look at Task Manager to see the performance, registry, events, devices, some basic remote scripting, access to the control panel, perfmon, disk management, file explorer, all remotely on Nano server. So remember, Nano server, you still want to do basic things, right, like browse a file system. You're now able to do this, but through this remote third-party tool. Now, the big downside of SMT, it requires cloud-based connectivity because what it's actually using behind the scenes is the Azure Resource Manager component, ARM. And what Azure Resource Manager is, it's a service developed in Azure. There's an on-premise version, but it essentially centrally manages, optimizes, and communicates across all these different types of components. So that's one of the hard dependencies in deploying SMT, is you have to go set up and run this Azure Resource Manager as part of it. So if you're already very integrated with the cloud, already using a lot of Azure, Azure Pack, starting to look at Azure Stack, this is going to be a great tool because you already probably have the skills, the technology, and the connectivity to do this. If you're an SMB, this might not be the right fit for you because, again, you got to go do this additional configuration and monitoring. I'm going to take questions at the end. So the other types of options we have are managing with the full GUI interface. So today we released our Nano Server Management product, but let's go ahead and switch over to take a look at all of these other types of management products. We'll show you what works, and we'll go and show you those limitations that we have with them as well. So first, we're going to go ahead and wrap up our installation here. So you see it took a couple of minutes to kind of run through everything. We've gone and installed the image. We've got our WIM file, and we've got our virtual hard disk. So let's go ahead and actually take a look at what we see from our output here. So I'm going to go back to my C drive, going to go to my VHDs, and here we go. You see we now have this new virtual hard disk, Nano Ignite. Again, I want to point out this deployment step is very different. What you're now doing is creating a virtual hard disk, and you're either going to attach that to a VM, or you're going to go and attach that to bare metal, booting from a VHD. But the next thing we need to do here is, I've just gone ahead and set up that very base image. Remember, we start with nothing, and we add pieces to it. So if I want to go ahead and actually add some different features or roles to this that we want to install, we'll go ahead and add the package installer. And what this is going to do is it's going to go and suck down all of these different possible add-ons that I can use so that I can then go ahead and deploy them. So from here, we can go and install the compute components. This means that my virtual machine can support Hyper-V as a host. We go and install the storage components. This means that we can go and use things such as storage spaces. We'll go ahead and install containers. So I can run this, use containers. And finally, clustering. So that we can create either a physical cluster if it's on hardware, or we can create a virtualized guest cluster as well. So what we've done now is we've gone and we've set up this great virtual hard disk, Nano Ignite. Now, next thing that I'm going to do here as part of my setup is I'm going to go and copy it to my shared storage. So I generated this on my local disk, but I'm going to go put this VM on a cluster. So I'm going to go ahead and move this to cluster shared volumes. So for that, I'm just going to go to whack Nano server. C drive, go to my cluster storage, and go and place it in one of my CSV volumes. If you take a look at the size here, it was about 500 megs. So that was the basic 460 megabytes for the core image, plus I installed several of those additional features and services. So it made it about a half gigabyte total. We'll go minimize that. Let's go ahead first and take a look at Server Manager. What are my management options through Server Manager? So they are relatively limited, but they give you the base functionality for creating and managing your storage. So down here, if I go ahead and take a look at my file and storage services, I could go and see that I have different volumes set up, different disks, storage pools, shares, iSCSI, cluster shared volumes. All of the native Windows storage options are supported by Nano Server. Now, in addition to that, Nano Server is also going to support things such as deduplication. It's going to support replication. So you can replicate using Hyper-V Replica from a Nano Server host as a target, or replicate a Nano Server virtual machine. Really, there's only a couple of components that aren't supported in Nano Server. The first, the big one that some people are concerned with, is Remote FX. Now, if you think about what Remote FX is, that allows you to do high-end graphics processing on a virtual machine. Doesn't really make sense with a Nano Server, right? You don't have any graphics. Some of the other components that you're going to see that have limitations are actually remotely running scripts, remotely running services within each of those different virtual machines. Now, the next thing that we're going to take a look at here is Hyper-V Manager. So within Hyper-V Manager, what I've got here are 3 virtualized Nano Server hosts. So I've actually done nested virtualization here as well, where I'm running VMs within other virtual machines. So I've simulated 3 Nano Server hosts here. But from the outside perspective, whether it's a virtualized host, a virtualized machine, I have all of the same functionality of a traditional VM. Remember, from the outside world, we want to think of Nano Server just as any normal VM. It's once we open it up, get inside, that it's different. So from here, I can go and configure all of my traditional settings: memory, storage, network, and hardware. I could go and configure my replication settings. I can configure my switches. I can do checkpoints. Pretty much everything. With, again, the exceptions of anything that's going to go and peek inside the core operating system. So Hyper-V Manager, for the most part, it's going to work well with Nano Server, give you all that basic functionality. Let's next go ahead and switch over to failover clustering. Here you see Failover Cluster Manager. Now, from here, you can see that we have a couple of Nano server VMs already deployed. And for the most part, they look like they're running pretty well here. Now, this is the first area where you'll start to see some limitations around managing Nano server when we're trying to peek inside that guest operating system. So for example, one of the features that we have within Hyper-V, within failover clustering, is guest monitoring. Now, a lot of people even don't know about this feature. But what this feature does is it actually will go and monitor the services running inside the virtual machines for their health. So we could see, for example, if the print spooler is healthy. We could see if any of my own custom services are healthy. And I have the ability to restart from the host inside that virtual machine. But here's an example where we start to see those limitations, right? We don't have those same PowerShell commandlets that live within that VM for us to call to go and remotely access and connect to all of these different services. So again, on the outside, everything's good. Once you start to peek inside, you really do start to see a lot of these limitations here. But other than that, all the same core functionality is available, prioritization, live migration, everything that you kind of want to expect here. So let's actually go ahead and launch the console here. And we can take a look at what it looks like within the VM. So here is our virtual machine, and this is my logon screen here. Pretty basic, huh? Administrator. My password. Actually, I'm going to go start my other Nano server I'm about to deploy. That one's using an old password. So let me go and switch over to my other interface where I actually know what my password is here and go and launch. I'll go and launch the next one. So actually, for my next step, what I'm just going to do here is go deploy this brand new Nano server that I've just created. So let me go ahead and create a new virtual machine here. Now, I can go ahead and I can do this through pretty much any console, Hyper-V Manager, Failover Cluster Manager. I'm going to do this through Five9 Manager. I'm more familiar. We go and create a new virtual machine. We go and give it a name. So we'll call this our Nano server for Ignite. We could store the image in a different location if I want, make it highly available. Generation 1 or Generation 2. Number of virtual processors, we'll drop that down to 1. And startup RAM. Great thing about this, very little servicing, very little RAM that I actually need. So I'll drop that down to 128 megabytes, connect it to a network, and from here we'll go and use an existing virtual hard disk. So this is where we're actually going to go and attach the VHD to my brand new virtual machine. So I'm going to go to my C drive. Cluster storage, disk 3, and go and select my brand new virtual hard disk. Confirm all the settings, and we'll wait a minute for this to boot up. But again, very fast deployment, very fast setup. That's one of our key goals, key initiatives, to go in and deploy in this Nano server. Now, what we're going to see once we go and boot it up after the login is, again, this very basic functionality. You got a couple different options of how to connect to it. You use the password that you set in advance here. And here's our Nano server. We'll go ahead and launch it. Here's another important tip that I missed here as well. There is no RDP, no remote desktop protocol that runs on Nano server. So when you're doing your connections to Nano server, you're actually going to go and connect directly through the VM console. So we'll go launch it up. It's probably going to treat me. I think it's a real virtual machine, but you'll see in a second, we turn into Nano server.
Can we ask questions already?
Yeah, sure. While this boots up, go for it.
Well, the question is two parts. Number one, can you automate the feeding of the password with a variable? Does it accept that? And the other question is group policies.
So question here is first, when we go and create this, how automated is it? Can we pass it variables such as a password? Yes, you can. So you can actually build all the whole Nano server creation and deployment inside a script, and you can pass it different parameters, names, variables, passwords, things like that, yes. Second question he had here is, what about group policy? Can I go and remotely configure group policy on it? Yes, you can, so long as those group policy commandlets are available with the PowerShell core service. I believe most of them are. I can't confidently say that every group policy setting is available through the PowerShell core, but in theory, if that is, then yes, you'd be able to do the group policy as well.
Can you run containers in failover clustering?
Can you run containers inside failover clustering? I believe so, but I'm not that confident. Can anybody answer that for me? We'll have to get back to you on that. I believe you can. I have not tested that one myself. Great question here.
Will the Nano server accept invoke commands from another remote PowerShell instance?
Will the Nano server accept invoke commands from a remote PowerShell instance? For that, you have to go and turn on PowerShell remoting. Assuming that you have that, I believe it can. So if you've gone and turned on all the different settings, opened up the ports to allow the PowerShell modules, PowerShell remote connections, I'm fairly sure you can. Can't give you a 100% answer on that one, though. So here we go. We've got our Nano server up and running. And this is the awesome GUI interface. This is what you guys waited 45 minutes to see. Woo! So as you see here, pretty limited. So actually going back to that PowerShell question here, you got to go configure these different firewall settings, open up Windows Remote Management, and then you should be able to do all the different remoting. So as you can see, very, very limited functionality in what you can do here. We hit enter, enter to confirm, and we've gone and turned it on. And the rest of the GUI interface looks just like this. So if you guys remember server core, you at least get the sconfig, like the kind of step-by-step, select this option, do a little bit of PowerShell. You really get none of this within Nano server. So how can you really go and do all this monitoring and optimize in Nano server? So a couple of things that we like to do here to go and make Nano server management even easier is using the ability to go and clone your host settings. So we have the ability to go and select a Hyper-V host, go and configure any different type of settings here, and go and apply that same setting to the other hosts. Now, a best practice anytime you use virtualization is you always want to make sure that your hosts are configured the same way each time for consistency, so that that VM runs the same way on the first host as it runs on every other host as well. You want to make sure that you have different types of monitoring available. So what we can do is select a different cluster, host, virtual machine, or even a Nano server image, and get real-time login and reporting. You want to make sure that you have the ability to monitor at the host level or at the virtual machine level so that you can see that performance of the different VMs. And another best practice, if you have a System Center or other tools like Five9 Manager, is you can go and configure dynamic optimization or load balancing. So you take a look at each host, look at the performance metrics, and if you get any thresholds for CPU, memory, disk I/O, or network I/O that are passed, we can go and trigger a live migration, go in and move in that VM over to another host. Now remember, Nano server is brand new for all of us, so there's going to be a lot of challenges you see the first time you use it. So it's important to make sure that you have configuration options that will send you alerts as well, so that anytime you have a problem, anytime you go and see a crash, you could go and trigger an email alert using something like Operations Manager with System Center integration, or other third-party tools like Five9 that will allow you to go and automate monitoring and different types of alerts here. Capacity planning is also going to be an important one to start to think about when managing your Nano server hosts. Again, a lot of these third-party tools are not Nano server aware yet, so you might start to run out of capacity, but just think there's different performance metrics. In fact, there was one Microsoft customer that said his Nano servers restarted so fast after they crashed that his monitoring solution didn't even detect that they had crashed. So even though Nano Server can be great in that it is so fast, sometimes it can be too fast if you don't have the tools and the processes in place to really be able to optimize it that are Nano Server ready. So kind of keep all those best practices in mind. Nano Server is going to be great. It will be the way of the future, but you want to really start proactively thinking about how am I going to efficiently manage it? How am I going to go and update all of my different tools to be aware of it as well?
What about management via SSH?
Management via SSH. So SSH shell, like for Linux, you mean?
Yeah, because it's supported in Linux.
That's a great question. Honestly, I don't know the answer to that. So the question is, can we do SSH as a remote way to go and log in and connect to a Linux operating system running inside Nano Server virtual machine? I don't know. I mean, that might be another question where if you have the correct firewalls, the correct remote management in place, it may work, but I'm afraid I can't give you a positive answer on that one. So to wrap it up here, here's some great resources that we have available. The best thing is the TechNet guide. Search Getting Started with the Nano Server. It's going to give you a very detailed step-by-step documentation covering everything we discussed here. Windows Server TP5 is currently available, but stay tuned very shortly. We will have RTM so that we can get the best version here. Channel 9 has its own Nano Server channel, so you can go check out videos. People like Jeffrey Snover are on there talking about all the great things from Nano Server. And of course, if you want to go try different management tools, check them out, Server Management Tool, 5.9 Manager. With that, I hope you enjoyed the session here. I hope you learned a little bit about Nano Server, best practices, business case for it, and I really want to encourage people to try it out. Microsoft thinks this is the way of the future, and Microsoft is very, very receptive for feedback. You can email nanoserver@microsoft.com, share direct feedback, and it goes straight to the engineering team. So they can hear it, they can go and try to make this better. With that, thank you all for coming, and enjoy the rest of the show.